So how did I manage to go from this to what you just saw rolling across the floor over here? Running into obstacles and turning itself around. Well, that's what I'm going to show you here. I gotta be honest, when I first got this kit from the college I'm going to, it was pretty much already pre-built, minus the LEDs and a couple of resistors and wires. It mostly just had the two touch whiskers, these guys, and these two pairs of resistors on this breadboard, and the only thing it could do was run into stuff and turn itself around. I added the speaker and the LEDs and told them what to do in the code. So that's what I'm going to show you here. So the first thing you need to know is the fact that this little Boe-Bot thing here runs on a basic stamp microcontroller by Parallax. That's this little thing right here. That is the main CPU, the main processor. I'm sure probably one of these two chips is for memory, remembering what program is being put onto it and all that fun stuff. And across the left and right side of this microcontroller, you've got input and output pins, which correspond to positions over here as well. Over here, you've got VDD is regulated power. I think it's 5 volts. VN is whatever's coming in off of this barrel connector here. Currently, with 4 AA's, it should be around 6 volts. And then VSS over here is your ground. There's the basics on how this thing works. Now, in order for this microcontroller to know what to do with these servos, which are under here, with wheels connected to them, and anything else I put on this breadboard using any of these pins, I have to write code to send to the microcontroller so that it can actually run the robot. So in order to actually get started here, you need the software from the internet to actually code in BASIC and send it to the robot. This is the software you need from parallax.com/basic stamp software, blah, 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 blah. Get it, install it. It runs on anything from like Windows 95 all the way up to Windows 11 apparently, which is pretty cool considering they actually still support those old operating systems. So anyway, get it, install it. You'll end up with this little guy right here. I've already got the code and everything up and running, so you can see what is actually installed on this stamp in particular. Over here on this code window, you can see I've got a lot written in already. This here is for the speaker output. This here makes the LEDs flash side to side when you first turn it on. Actually, this makes the different output from the speaker, and then this flashes, and then it continues and does the actual main loop, which is movement. And then down here, you have what you're sending to the servos to go forward, left, right, and reverse, respectively. Low, 0, 6, 11, 15, and high, 5, and 10. That lights up the blue, what I call reverse LEDs. And then you have all these getting shut off and high on 0, which would be right turn LED, and same thing with the left, and the same thing with forward for headlights, if you want to call them that. They're green, so they're just kind of headlights and whatever. This is pretty much the only way I've found to make the lights actually stay on instead of just flash when you start the code, so it works. And like I said, I've got all this comment stuff up here. This actually, if you have the bot plugged into a computer, you can actually read the messages as they're being executed on the controller. So I will go ahead and show that real quick. We'll go up here, we'll go COM port 4, and then I'll turn the deal on. As you can see, it comes up, and actually there's nothing plugged in right now, so the inputs are going all over the place. They're floating, in other words. So right now, it thinks that it is stuck, so it's just going to keep on going until it's no longer stuck. Okay, yeah, let me show you this real quick. I've got it plugged into the USB on my computer. It's just USB to serial. I think that's what that chip is right there. Just the controller for USB to serial. On position 1 on this board, it gives access to let the code do what it wants without actually running the servos. Now, if I were to turn the servos on, that would go to position 2, and this thing wants to start moving all over the place, which is really fun. Right now, it's using pins 8 and 9 in the code. You can see that right here where my mouse is. If N8 is 0 and N9 is 0, then go back and double left because you are stuck against a wall and you can't go left or right. You have to go backward. Anyway, so pin 8 and 9 are actually referring to this P8 and P9 right here. They want a high signal when there is no obstruction. So what we need to do is actually give it a high signal, which I can do with these two resistors right here. What this is called is actually pulling the pin high. Pulling the pin low would be grounding it and then waiting for a high input. So let's see. Pin 9. Oh wait, nope, that's pin 8 actually. Pin 8 is now going high. So now it's backing up, turning left, backing up, turning left. It's no longer double lefting because I have actually set the other side high, so now it's only on one side that it has issues. So now I'm going to actually set pin 9. Boom. Notice it's going crazy now. That's sending data to the computer, which is saying moving forward, moving forward, moving forward a whole lot of times. Like that is going to sound crazy when I speed it up, so just enjoy that. Now, pins 8 and 9 are just waiting for a grounded input from the whiskers that are not here. Now, the whiskers I'm talking about, you will see the manual talking about over here. So, navigation with whiskers. That's the program that was actually on this thing when I first got my hands on it from a prior student, most likely. So, I didn't know that at the time. I didn't know anything about this thing. I just pulled it out of the box, turned it on, checked it out. Blah, 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 blah. It only had one of these whisker things installed on this side, but it still had both of these pin headers on the breadboard, so it had the inputs for both, but only one whisker installed. It did what it was supposed to, but it wasn't fully built. I built the rest of it, and then I started making changes in the code as well. So this here. Basically, the code here is right here. It uses N5 and N7, so on the board that would be pins 5 and 7. I changed it up. It's not a big deal doing that, as long as you make sure your code matches an N5, N7, else go forward. So N5 and 7 means it's a big obstruction. It's taking up both sides, so it's got a U-turn. You see, U-turn. And then if it's just N5, then it's the left. N7, it's the right. Back up, turn right, back up, turn left, and it does what it's supposed to. Well, I also went up in the instruction manual and found where you can write out to the LEDs, you can write to the speaker. Let me go back to the table of contents here, and I can find that a little bit easier. Okay, here we go. Here's the speaker we're talking about here. It's a piezo transducer, so that's all that is. So you come down here, there's code around here somewhere. There we go. Freak out. Freak out, yeah. Frequency output. So here it's using pin 4 as the output for the speaker. I think I had mine on 2. I don't remember. But 2000 is the duration of the tone, 3000 being the actual tone itself, and this can be 3000 hertz for 3000, 3 kilohertz. I kind of made a mess out of mine and had 2000, 3000, 1000, 2000, 1000, 2500 at 10 millisecond intervals. So let me just put this speaker on here real quick on the 2-pin. Get in there. And then we can take this wire here and take the other side to ground. So from here to ground. And then when I turn it on, it doesn't work because I'm not on the right pin. There we go. Why are you not working? Did I put the speaker in wrong? Is it actually polarized? It's polarized. Okay. And then we can go, yeah, that's 2,000, 3,000, 1,000, 2,000, 1,000, 2,500 hertz in about a 0.6 second interval. So that's that. Easy enough. Now, it's a pretty good idea to note that this code here is not what's actually being written to the microcontroller. This code is being compiled by the program into machine code and then being written to the microcontroller. So you can't exactly download the code off of the microcontroller. So the fact that this thing had code already installed, I had to actually figure out what was on it by basically just reading through the manual and deciding, oh, that's what it was. So given the fact that it had whiskers, I knew it had to have something to do with the navigation with whiskers section. I come down here, I'm looking at the code, it does this when this happens, it does that when that happens. So I kind of just figured it out from that and then was able to write my own file with that code and have it do what I wanted it to do. Well, that worked out pretty well. We got the speaker, we got the servos. The servos are already on the board over here. They're just over here on the X4 and X5 connectors, which are actually on pins 12, 13, 14, and 15. Also over here, and you can actually hook these up to additional items. You can actually have 12 and 13 show an indicator, LED. You can put an LED on 12 and 13 to show that data is being sent to the servos. So let's see if we can find LEDs. Building and testing the LED circuit. Blah, 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 blah. That is not here. It starts talking about the servos for a minute for some reason and sending out debug stuff, which is this guy over here. But we're skipping that for now. So LEDs are designed for a certain amount of current, certain voltage. I really don't think the voltage matters as long as the current is correct. But anyway, the current has to be right. So you have to use resistors if you're going over like 3 volts. Most LEDs can handle 3 volts just fine. No big deal. But if you go over that, then you start doing over current and then the LED explodes. It's fun. So you need a resistor. The most common I use is the yellow, violet, brown. And then that's going to be 470 ohms. The resistors I put on here earlier are actually 10K ohm resistors. Brown, black, orange is 1, 0, and then orange is times 3. So that's 10,000 ohms. There's your resistance values. So brown, red, orange, yellow. Okay, gold, yeah, is 5%. I thought that was right. So most resistors I mess around with are 5%. Let's move on. So we got the LED stuff here. You're looking at this, blah, 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 blah. LEDs are polarity sensitive. You have a flat side and you have a round side. The round side is plus, the flat side is negative. That's basic. So we get here, we're going down to the code now, wherever the code actually is. We know about that. I just discussed that. Okay. On the microcontroller, you can send high 13. That makes pin 13 half voltage. So I'm thinking it's probably 5 volts from the microcontroller. So we have to use the 470 ohm resistor in order to get a proper value. So my code uses pins 6 and 11 for, we'll say, the headlights. So we'll go over here. We'll stick one leg of this resistor in pin 6, and we'll stick the other leg in a random spot in the breadboard. And then we'll take our green LED here. Like I said, one side's round, one side's flat, so this side is my positive lead, and it needs to go there on the other end of the resistor, because each one of these columns, or actually rows of 5, you got columns and then rows, each one of these rows of 5 is a separate circuit. So you can have them all adjacent to each other and not connected, but 1, 2, 3, 4, 5 are connected. And then we take another black wire over here and we'll stick that in VSS and the other side in for that. And then we'll turn it on. No audio because I took the speaker off. And now we have light on pin 6. So that's pretty cool. And if I move this resistor here over to pin 11, I will also have that light because pins 6 and 11 are the headlights for this vehicle. That's fun. So now that we have all the basic stuff figured out as far as the code is concerned, we go high for on, low for off. So you see I'm turning all the lights off and then turning the headlights on. Here I'm turning all the lights on and going high with 15, which is the left side, and so on and so forth. And like up here, I'm alternating them back and forth when I first turn the device on. The left and right turn signals flash for a bit and then shut off. 1 to 10, so on and off for both sides 10 times, and then it continues on to the next part of the code, which is this. So now that we've seen the code, I'm going to actually build the thing with the circuit that I had on it before, and we will go from there. Diva, I cannot have you doing this to me right now. Come here. Okay. My cat is in my way. She wants all of my attention right now. Diva, you are driving me a little crazy here. And there you have it. It's done. No wires are touching that should not be, so I can just turn this thing on. We got speaker, we got left and right LEDs, we got front LEDs, and we've got reverse LEDs. Everything's working. Good deal, good deal. Everything works. Coolness. So now, when this whisker touches a wall or something while this thing is rolling forward, it bends back and touches that pin header, indicating that it needs to back up and turn left. Same thing with this side, only it backs up and turns right. And this is accomplished by this code that I, well, mostly copied from the manual. But anyway, you come here, if both are 0, then it's against the wall, both pins are touching their respective headers. Like, let's say both pins are touching the respective headers. So it's basically stuck, so it stays on left a little bit longer. You can see if I had this thing plugged in and the debug terminal was actually functional, you could see that it goes left twice. I'm totally freaking this thing out right now. Okay, so the debug terminal says it's moving forward, moving forward, moving forward. Yes, we are expecting that operation. Now, backing up, turning left. So, both of them are going at the same time. We get 2 turning lefts because we needed to do a full U-turn. And then, of course, we have turning right. There we go. So that's all accomplished by this code here. If one, then go sub. What is go sub? That is a sub process, which is these down here. It's like a function in certain other coding languages. So I'm just going to talk on the code now. So forward would be a function, left would be a function, right would be a function, and back is a function. And if everything is not zeroed out, so it should be going forward, then this runs, so many times a second. and it just keeps saying, go to the forward loop, go to the forward, go to forward, go forward. So it just keeps running forward. Pulse out is what runs the servos. Testing 58. So we'll go to page 58 and we'll look at the code for that. As long as this thing is rolling forward, there are continuous pulses being sent from the microcontroller to the servos. Blah, 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 blah. It works. That's all I can say. The rest of the code is pretty obvious and easy to figure out, like the whole lows and highs for the LEDs and the frequency outputs for the speaker. Those are pretty easy to figure out. Pulse out, that's a little different. So you notice I've got like 4 PC 0 to 40. That's how long this particular section should run. And the variables, they have to be called up here. They have to be actually defined before you can use them in the code. I don't know much about PBasic and all of that, but that's apparently how it works. I'm more used to C++ like used on the Arduino boards, or Python, you know, stuff like that. But these boards run what they run, so there you go. That's what I have to work with. So 1 to 10, that one's pretty clear. It runs this section 10 times, and then this runs as long as the system is on beyond that point. So that pretty much covers that. Just gonna let this thing run into a few more walls, I guess. And it can't do that while it's plugged in, so we're just gonna... My door's open. Maybe let's see if it can go out the door. That'd be fun, right? Power up. Don't ask me why I set it up to do that. It just felt like a thing I wanted to do. Uh-oh. It missed. U-turn. Hey, at least we know that works. Not bad. I think I've got the whiskers set too far out. I should set them back a little bit so that they actually respond quicker. Which, like I said, you can do that by just going in here and bending these guys a little bit closer to the pin header. Well, now the pin headers are kind of pushed back a little bit. Like I said, you can get them pretty close without actually touching and make it super sensitive. Just like that. Now, in the manual, like, you have the navigation with whiskers. That's the basic thing. If it runs into something, back up and turn around. Now, what if it actually gets stuck? Then we come down here, and I know, here we go, artificial intelligence and deciding when you're stuck. Apparently, this manual has code for, let's say, if it gets stuck in a corner and it can't move anymore, then it just knows that it needs to go back. But I didn't bother messing with all of this, so it actually still uses the original navigation, but then it has actually another section up here. Ah, this is different. So yeah, I could also play with the code and make it do this too, but I'm just going to leave it for now. So anyway, there's that. There's how that works. Another project, or I guess something to play with, I was working on with this little guy over here. An Arduino Nano knockoff running an 8x8 LED matrix. That is something I basically just copy and pasted a code snippet off of Google to make work. Just because I was interested to see it work at all. I might use it in one of my own personal projects. Plug that, and you can see that works. It continues, and then it turns into me. Boom, AK. Yeah, I might have changed the code a little bit to make it display that for a very extended time, just for the heck of it. Because it's me, right? So, there you go. That's my fun stuff. And the code for that is actually done in the Arduino IDE, which I will bring up real quick. So we have the LED pin rows, and we got the LED pin columns, and like the wires are going all over the board because of the way the pinout of the actual matrix is set up. So like pin 1 does not reference row 1 at all, or column 1 even. It's just kind of pins 1, 2, 5, 7, and then on this side 9, 12, and 14 are the column pins. Or no, that's the row pins. And then the ones with the white wires are the actual column pins. So it's not linear by any means. But I've got them set up on the Arduino as if they are. So output 1, analog output, I guess that'd be digital output 2, 3, 4, 5, 6, 7, 8, 9 are pins, or actually rows 1, 2, 3, 4, 5, 6, 7, 8. And then digital pin 10, 11, 12, 13, and analog pins 0, 1, 2, 3 are columns 1 through 8. Respectively. And that's what you get from that. And so we come down the code here, and this is the actual matrix itself, but it's reversed. So like the top of my A, I'm on star 4. I made star 4 here. These two are just duplicates of 2 and 3. So mine is star 4. The top of my A is here, and then the top of the K is here, and then you have the second line, the third line, the fourth, fifth, and that's the empty line, and then the full line, and then yeah, the rest. So that was another little fun project I just wanted to play around with, and I did, and it was fun. And I think that's going to cover this video pretty much. It's long-winded. I meant for it to be a lot shorter, but there you go. I tend to be long-winded, so that's it. But I hope even if you didn't learn something, you at least enjoyed the video. So with that, I will end it. Have a nice day.